Hello, for my kitchen chemistry, I'm looking at asparagus versus broccoli. Why should you cook them in different ways? And why this subject? Well, in higher chemistry, Unit 2, Nature's Chemistry, you are informed that candidates should be able to predict the solubility, the boiling point, and the volatility of a compound from its structure. So things to consider. Are there groups that can lead to hydrogen bonding? So that's OH and NH groups. What about a polar covalent bond in there? Is there a permanent dipole? And what about the size of the molecule? A bigger molecule is going to have more, have greater London dispersion forces. So it's going to be less volatile. And then also, how will this affect the solubility of the compound? So polar compounds will be soluble in polar solvents, whereas non-polar compounds will be soluble in non-polar solvents. Now, what's this got to do with broccoli and asparagus? Well, we're going to cook our asparagus and broccoli in two different ways. So we are going to boil them on the back hobs, which I'll put on now. So that's also known as blanching, so you just add some salt water. And then on the front hobs, we're actually going to be frying them in oil. So if we think about our solvents then, we've got polar at the back, so we've got our water, and then we've got non-polar at the front, we've got our oil. Now, keep it fair, we're going to fry the same amount of broccoli and asparagus. So, in they go. And then we're going to boil the same amount of broccoli and asparagus at the back. In they go. And we'll let them fry away. Now, when it comes to the difference here, what we're actually going to see is that there is different flavour compounds. So you can eat them raw, and they have that kind of earthy flavour, both of them. But in asparagus, the main flavour compound is this, asparagic acid. So you can see that it's an acid up here, so a very polar group, a carboxylic acid, actually. And then it's actually got these sulfur compounds in the background. So they think this is metabolized into sulfur-containing compounds, so like thiols, and thiols are very smelly. So this is why asparagus makes your pee smell. But then it's actually, we're going to see the other influence of that. So this compound, it's quite small as well, so we expect it to be volatile and we expect it to be polar. And what that means is if you boil your asparagus, then actually you end up dissolving out these polar molecules into your solution. And we can see that. So I'm going to do a Blue Peter, and this is one I've done earlier. So if we boil it and then we can strain it, what we find is that when we look at our solution, so we look at the solution. So this is asparagus and this is broccoli. So you can see, hopefully you can see, that one is a lot darker than the other. Now, that very much tastes like asparagus. That still tastes a little bit like broccoli, but not nearly as strong as the asparagus does. Now, what about when we compare the flavour? So, as you can see as well, with the asparagus, it becomes very spongy, and actually you can kind of pull it apart. And the flavour, well, there is a bit of an asparagus taste, but it's quite dilute. Now compare that to the broccoli. So broccoli still retains its kind of firmness, a little bit of a crunch. So I boiled these for 8 minutes, but we still have that broccoli flavour there. Now, when it comes to boiling, when it comes to frying our broccoli versus our asparagus, something different happens. So, again, here's one I did earlier. So you can see, now with the asparagus, actually, it's a lot harder to break, doesn't really come apart. And the flavour is much stronger. Now, compared to the broccoli still does have a flavour, but certainly with the asparagus, it's actually much stronger, more flavourful. And so I actually got the inspiration for this demonstration from Histon Blumenthal, who he has a video on this exact demonstration. Although he adds, truffle and garlic to his fried asparagus, and is, no wonder it tastes better than the boiled stuff. But he also talked about actually the kind of cell structure of the of your broccoli versus your asparagus is different. So I actually have a microscope, so I can show you that this is the cell structure for broccoli. So it might be quite hard to see, but it kind of looks like there's lots of cell walls there. It's quite rigid cells. So that's uncooked. And then this is the cell structure, say magnification for the asparagus. So you see that these cells, they're not quite as thickly packed. They don't seem to have that rigid structure. And so what happens when you cook them is that these cells actually kind of burst. That's why the asparagus comes apart. It releases all those asparagesic acid molecules. You lose them. They're volatile. They're polar. They dissolve in the water, whereas they don't in the oil. So that is why you want to use oil when you're cooking your asparagus. Just fry it, or grill it. Anyway, don't boil it because you lose those molecules. Okay, well, that was my kitchen chemistry. Hope you enjoyed it, and see you later.